Hello and welcome to DCC Model Railway Signalling. Today I thought I'd demonstrate a semaphore signal example representing an absolute block section. So here is our schematic, and you can see it comprises a number of sort of home signals within our block section, protected by a distance signal on each incoming line. But what we've got a block instrument for communicating and coordinating train movements with the next block section along the line, which would be in reality an additional signal box. So the interlocking of the signals and the points is pretty much as my previous videos, but the difference here is the outgoing signals, if you like, the block signals controlling access out of this block section to the next section, are interlocked with the block instruments. And so, for example, I cannot set that to off until the signaller in the next block section sets the line to clear. So we'll just demonstrate that now. Set the line to clear. That's repeated on our repeater instrument. And now signal 4 is unlocked, that can be now taken off. So that's one aspect of block signaling. I'll just return that to line blocked. The other thing is that the distance signal should be locked if any of the home signals are on. So for example here, I can just demonstrate that, that's locked. And if I switch off some of these other signals, I just need to put that facing point lock on. That signal off, that signal off, but that's still locked because the last signal in our block section is still on. So again, if I unlock that from effectively the other signal box communicating to our block instrument, and unlock that, and now the distance signal can be cleared. So that's the interlocking. The third thing I'll quickly demonstrate is some of the automation aspects. If you don't want to spend all your time signalling your model railway layout, then we've got some automation that can sort of help us out here. So if I enable the automation, so what I've got here is the signals in the block section will automatically be overridden if any signal ahead is on. So if I actually try and put those signals on, you can see I've activated the buttons, but the signals aren't actually on because they're overridden by the fact that that last signal in the block section is on. So what does that mean in practice? If I just put a train in here, how it would actually sort of work is a train is approaching the block section. It passes the distance signal and starts slowing down, prepared to stop. But then when it approaches the first home signal, the signaller would then sort of clear that signal as an indication to proceed to the next one. So if I just click on that, representing the approach, you can see that signal's cleared. Now if I click on the signal passed again, you can see that signal has automatically reverted to danger. Look at the next signal, it's exactly the same operation. As soon as the train approaches, the signal changes to off. When the signal is passed, the signal reverts to on, and it proceeds down the line. And finally, approach that signal and pass that signal, and now it's sitting at the final signal to go into the next block section. So that's basically it. A bit of automation. I won't go into the sort of nitty-gritty. I'll probably do another video on that later. But that just gives you an example on things that can be achieved. And it's probably worth noting that although I'm simulating the adjacent block sections by block instruments on the same schematic here, because of the networking capabilities of the application, you could be running up these other signal boxes on a different machine with a different schematic, and you can then just do more communication between the signal boxes in a prototypical manner. So you can sound the telegraph. in each box, and again signal to the other box the sort of state of the line. And that's it. So thanks very much for watching. Goodbye.